On Thursday, we're going to not do any calculations. We're going to experimentally determine a titration curve. And so on Thursday, we're going to put a pH meter in the solution and monitor the pH as we add sodium hydroxide to the solution. The solution is going to consist of an unknown acid. It's going to be a solid acid which we dissolve in water. When we dissolve in water, we're going to get some initial pH here, and that would just be the aqueous acid solution. And then, since it's unknown acid, we don't know, exactly where the equivalence point is. In order to calculate the equivalence point, we'd have to know how many moles of acid we have. We don't know how many moles of acid we have. And so what we need to do is we just need to record our data. And so ideally, we record it at 1 drop intervals, because the burette, you can get a half a drop, but it's too much hassle to get a half a drop. Actually, a half a drop we can't really get in a pH titration, because in order to get a half a drop, you have to add water to wash that half drop in. And then if we add water to wash that half drop in, then it's going to change the pH. And so we need to take this at 1 drop intervals. And then when we get close to the equivalence point, it's going to jump up within 2 or 3 drops, and it's over. And so this would be, just the next drop would shoot up, and the next drop shoots up, and the next drop shoots up. And then it flattens out again. So we go back to our 1 drop intervals. Ideally, we'd like to use the entire burette worth of sodium hydroxide. And the burette, we're going to end this around 50 milliliters. We don't have to fill it to the 0 mark and then drain it down to the 50 mark. We'll just get about 50 milliliters. And so we're going to go well beyond the equivalence point. Hopefully the equivalence point occurs somewhere in the middle or in the slightly right of middle, somewhere around here. Okay, so how many pH measurements will that require? So if we use the full burette worth of sodium hydroxide, that's 50 milliliters. 50 milliliters divided by 0.05 milliliters per drop gives us 1,000 drops. That means taking 1,000 pH measurements. Have you ever taken a pH measurement? Okay, how many have not used a pH meter before? How many of you have not used? Quite a few. Well, a pH measurement takes like 30 seconds, minutes. Sometimes the pH is not stable, so you got to wait until it's stable and shake it and stir it and this kind of stuff. And so let's say it takes 30 seconds to take 1 pH measurement, 30 seconds. And so that would be 30,000 seconds. Divided by 60 seconds per minute, it gives us 500 minutes. Divided by 60 minutes per hour, that's 8.3 hours. It'd take us 8.3 hours to do 1 titration. That's assuming that we take a reading every 30 seconds, which probably isn't going to happen. It's probably going to take longer than 30 seconds to get a reading. And so it's impossible. And so what we need to do is we need to take readings at larger intervals, like a half a milliliter. Half milliliter intervals would be about 10 drops. Again, don't use drops. We're going to read the actual volume on the burette. And so if we do half milliliter intervals, we're taking readings about every 10 drops, which means that we might miss this entirely. That is, if we're doing 10 drops, let's eliminate these 4, 5, 6, 7, 8, 9, 10. We got a gap there. That's a half a milliliter gap. We don't know where it went up. Did it go up right away, or did it wait until the middle and then go up, or did it wait until the end and go up? So we don't know where the equivalence point is because we got a 10-minute window where there's no data. And so we can't afford to have that. And so what are we going to do? Well, what we're going to do first is we're going to do a sacrificial titration. That is, we're just going to do something called a trial titration, in which we are not going to measure pHs. We're just going to use phenolphthalein as the indicator, where the equivalent. So the phenolphthalein is going to change pink at some milliliters. Let's say it changes pink here. Well, then that means the equivalence point is roughly here. And so weak acids will form a salt in water that's salt's basic, so the pH should be greater than 7, so phenolphthalein should be an excellent indicator for that. And so we're going to do one trial titration in which we just take one piece of data. That one piece of data is, where did that phenolphthalein change color? And if we know where that phenolphthalein changed color, that's got to be close to the equivalence point, right? And so we're going to just do regular standard titration in which we just monitor the phenolphthalein color. Once we know about how many milliliters that took for how many grams of acid, then we can do a simple calculation to figure out where it should be in our pH titration. So we'll do that on Thursday. And I'll talk more about it. We'll work through it together. But today's lab, we want to get familiar with the pH meters first. Our pH meters, we're using these LabQuest systems here. The LabQuest system accepts many different probes. For this experiment, we'll be using the pH probe. The pH probe, you're going to plug into the lowest channel number, which would be channel 1. So we'll plug that into channel 1. These are battery operated, but the batteries are likely dead. So we'll plug in the AC adapter here. And so this will be our pH meter. The first thing we have to do with the pH meter is this. The probe gives off a voltage depending on what the hydronium ion concentration is. And that voltage is read by this, which is essentially a voltmeter. But what we need to do is we need to convert that voltage that's on the screen into a pH. The way we're going to do that is by using a standard. And the standard that we have are buffers. We have a green buffer, which is the pH 7.00 buffer, and a red or pink buffer, which is the pH 4.00 buffer. And so we're going to stick the probe in there, measure the voltage, and then convert that voltage into pH just by plugging it in. And so we're going to have to break up into groups because we don't have enough of these for everybody. And they're sitting over there. You don't have to check them out. And so just go ahead and grab a tray and let's go through the calibration procedure together. So we'll just set up the pH meter like this. These buffers are fairly expensive, so we don't throw them away after one use. They have large enough capacities that we can have multiple uses out of the buffer. And so what you're going to do is you should have 2 polyethylene beakers on the tray, 25 milliliter beakers. Put the pink buffer in the pH 4 beaker and the green yellow buffer in the pH 7 beaker. You don't need much. Just fill it up about 1/3 of the way. That should probably be enough.
All right, get a wash bottle of fresh DI water. All right, turn on your LabQuest system. Does everybody have a LabQuest system? Yeah. Okay, also goggles. I forgot to mention, you need your goggles.